in the videos that follow for these two sections, we are going to work through and solve the problems that you saw in example 5. But before that, we have page 5 of this note packet where I'm just summarizing everything we've done so far regarding compound interest versus future value of an annuity. We sum it up so that we're on the same page before we proceed. Okay, so at the top of page 5, we have the compound interest formula once again. It is the A equals P times 1 plus R over M raised to the MT power. Okay, again, A is the account balance, P is the amount of the one lump sum deposit, original deposit, R is the interest rate as a decimal, M is the number of compoundings per year, and T is the time in years. Okay, and then remember when you want to use this formula. Okay, cannot emphasize this enough. When you want to use this formula. Okay, if you are saving money, okay, and you deposit a one lump sum. Okay, so it's a one-time deposit. You forget about the money, you let it grow through interest. You come back so many years later and you figure out how much money is in the account. Okay, and there are no withdrawals. Okay. You can also use this for a compound interest loan. Okay, we talked about that when we went through example 5. We saw an example with a loan. Okay, so you could use it for a compound interest loan. Okay, again, you would be borrowing money where the interest is compounded. And again, you're borrowing one lump sum of money. That's what makes this compound interest. Okay, the last situation you might use this formula for is an inflation problem. Okay, something like we saw the housing example where you buy a house, maybe you bought a house 10 years ago, but then housing prices have been increasing at a certain rate, and you want to know how much the house is worth now. So that would be an example. Okay, so those are the situations in which you want to use the compound interest formula. Okay, I'm going to walk back to the chapter 3 formula sheet, and I'm also going to add on here the compound interest loan. I don't want to forget about that. Okay, so compound interest loan, we don't want to forget about that. All right, and now let's go back and review really quickly when you should use this future value of an annuity formula. Okay, so there's the formula, okay, for the future value of an annuity. Okay, a little bit more complicated than the compound interest formula, but the variables pretty much mean the same thing. Okay, A is the account balance, P is the periodic deposit that you're making because you're making those regular deposits with the annuity. R is the interest rate as a decimal, M is the number of compoundings per year, T is the time in years. Okay, so again, when you want to use this formula, it's a very specific situation. Here, you're saving money, okay, and you're making regular deposits into the savings account, okay, and there are no withdrawals, okay, and really that's the only situation that you would use this formula for, okay. We will, in section 3.4, we will see other annuities, okay, but they will have different formulas involved. You specifically want to use this annuity formula when you're saving money, okay? All right, so make sure you keep that straight, okay? You can either refer back to this page or go to your formula sheet, okay? The next thing I have on page 5 is this little box that's going to give us the M value, okay? So think back to your formula sheet. If I go back to the formula sheet, every single formula on this formula sheet, with the exception of the simple interest formulas, if you scroll through here and you look at all your formulas, every single one, okay, also excluding continuous compound interest. So not the simple interest formulas, not continuous compound interest, but all the other formulas involve an M value, okay? So that M means the same thing for all the formulas, and it's just the number of compoundings per year. So let me put that here. M is the number of compoundings per year, which we've already talked about, okay? You can also think about it as the number of times per year the interest is added to the account. Okay, so like I said, all these formulas, with the exception of simple interest, the exception of continuous compound interest, they're going to have an M value. So we're going to talk about what you should use when you see these particular phrases. So for example, compounded annually. Annually means one time a year, so your M value would be 1. Okay, if you see semi-annually, okay, compounded semi-annually, that's twice a year, every 6 months. So that's M value would be 2 times a year. Okay. Quarterly, we've already seen, quarterly means 4 times a year, so M would be 4. Monthly, there are 12 months in a year, so M would be 12 in that case. Weekly is going to be 52 weeks in a year. Okay, daily was that interesting one. Remember, with simple interest, we used 360, and you were specifically told that. Otherwise, you can use 365 because we're used to 365 days in a year. Okay, so for our M value, we'll go ahead and assume M is 365. I'll make a note on here with simple interest. We typically use 360 days in a year. Okay, but again, you would be reminded of that, so you don't need to think too hard about it. I would just use 365 unless told otherwise. Okay, so those are your M values. And you know, when I want to make a point here, since we're on the topic of M values, when you're dealing with annuities, remember when we mapped out the annuity and we saw we did compounded quarterly. So everything happened at the end of each quarter. Okay, so if something's compounded quarterly, at the end of the quarter, you will get an interest payment and you will make the next deposit. Those two things coincide. So how often you're compounding the interest coincides with how often you're making deposits. Okay, so just make sure you understand that. Okay, the last thing on page 5 before it jumps into the examples, solving the problems that we saw in example 5, is a little note about solving for time. Okay, I'm not going to go through this right now. When we work a problem, when we solve for time, we will come back and read this note. Okay. Time is going to be more of an issue to solve for now. When we did section 3.1, our formulas were much simpler and time was pretty straightforward to solve for. I'm pretty sure we did a problem where we had to solve for time and it wasn't any kind of issue. But now if you're looking at your compound interest formula or even your annuity, your future value of an annuity formula here, you see where time is located here. If you look at both of these formulas, look what I just underlined in red. The t for both of these is in the exponent. So time is much more difficult to solve for because it is trapped in that exponent. So I will walk you through the process. I will give you a few examples of both formulas where you solve for time and walk you through step by step about how to do this. And the little note at the bottom of this page is very, very important for when you're solving for time, when t is trapped in the exponent. So I'm going to put off going over that note at the bottom until we solve for time. Okay, so let's go ahead and proceed to page 6, and we will start working with the compound interest problems that we encountered in example 5.